Everyone, good evening. So here we shall solve some more KCET. Here we shall solve some KCET previous year questions on the chapter periodic classification of elements. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos or in and also in any other chapter of chemistry. If you have more difficulty, then please write the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that an element with atomic number 21 is. So if the atomic number Z is 21, then the element is scandium. Element is scandium. Since for atomic number 20 is calcium, so after calcium we have scandium, which is in group. So in group number 2 we have calcium in the fourth period, in period number 4, and in group 3 we have scandium. So group 3 means from group 3 to 12 we have transition elements. So it is a transition element. So option A is the correct answer. Or we can also write its electronic configuration. So if we write the electronic configuration of scandium, then it will be uh, argon 4s2 3d1. So it means the last electron enters into the d subshell of the penultimate shell. The last electron enters the d subshell of the penultimate shell. It means the third shell. Okay. So it means that it is a d block element. It is a d block element, or it is called as transition element. Then it is told the correct order in which the first ionization potential increases is. So here we have potassium, beryllium, and sodium. So sodium and potassium K, they lie in group number 1. They are alkali metals. And beryllium lies here. It is in period 2 in group number 2, and sodium lies in period 3 in group number 1, and potassium lies in period 4 in group number 1. Now the correct order of ionization potential is. So here, as we know, that down the group down the group the ionization energy or the ionization potential, it decreases. Ionization energy decreases, and across a period the ionization energy increases. Across a period the ionization energy increases. So it means that as we go like this, it will increase from left to right, it increases, and from top to bottom also it will decrease. So it means from um, so if we go upwards, the ionization energy will increase. So therefore, the correct order of ionization energy, the correct order of ionization potential or ionization energy is potassium less than sodium less than beryllium. So K, comma Na, then Be. K Na Be. So option D is the uh, correct answer. So in this order, it increases. So we have to write the increasing order here. Option D is the correct answer. Then here it is told the correct order of ionization energy of carbon, nitrogen, oxygen, and fluorine is. So as we know that across a period means from left to right, the ionization energy increases. Since why the nuclear charge increases. Nuclear charge increases. So the ionization energy will also increase. So it will be more harder to remove the electron from the outermost shell. So carbon, nitrogen, oxygen, fluorine. So uh, carbon we know that is in group number uh, 14. Nitrogen is in group 6, 15. Oxygen is in group 16. Fluorine is in group number 17. So and they are all in period 2 only. They are all in period 2. So from left to right, the ionization energy increases. So the correct order will be so the actual expected order that will be carbon less than nitrogen less than oxygen less than fluorine. But here, in case of nitrogen, the electronic configuration of nitrogen is so nitrogen is atomic number is 7, so it will be 1s2, 2s2, 2p3. So here we have half filled, and for carbon it is 1s2, 2s2, 2p2, and for oxygen it is 1s2, 2s2, 2p4. So in case of nitrogen, the 2p orbital is half filled. So it is more stable than the electronic configuration of oxygen. So therefore, the ionization energy of nitrogen will be more than the ionization energy of oxygen. So it means therefore the correct order will be, so here there will be one jump here, one jump will be there. So the correct order actually will be carbon less than oxygen less than nitrogen less than fluorine. So option C is the correct answer. Since here it is half filled electronic configuration is more stable. So since the nitrogen electronic configuration is more stable than the electronic configuration of oxygen, so its ionization energy will be also higher than that of oxygen. So it will be harder to remove the electron from this 2p subshell than in case of oxygen. So in oxygen, it is more easier to remove the electron from the 2p subshell. The oxide of an element whose electronic configuration is 1s2, 2s2, 2p6, 3s1. Now it means that the atomic number of the element will be 4 plus, so it will be 11. So it is the electronic configuration of sodium. Electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. Or we can also write it as neon 3s1. So it means the oxide of sodium will be sodium oxide, Na2O, which will be, so as we know that the alkali metal oxides are basic oxides. So it will be a basic oxide. Since why? Since the oxides of alkali metals alkali metals are basic strongly basic in nature. So it means that option B is the correct answer. Then here it is told the correct order of stability of metal oxides is. So here we have chromium oxide. So in in chromium oxide we have the cation is the cation is Cr3 plus, and in magnesium oxide the cation is Mg2 plus, and in case of aluminum oxide the cation is Al3 plus, and in iron oxide, means in ferric oxide, the cation is Fe3 plus. Now here the stability of the oxides, as you know, the stability of the oxides will be higher if the lattice energy or the lattice enthalpy of the cations is higher. The cations is higher. So if the charge on the ion is higher, if the charge on the cation is higher, then the lattice energy will be also higher. The lattice energy will be higher, and also if the size of the ions is higher, then also the lattice energy will be higher. So here Mg2 plus, so Mg2 plus, so magnesium and aluminum, they are um, in period 3, and then Cr3 plus and Fe3 plus, they are in D block, so they are in period 4. So in period 4 we have Al3 plus, no, we have Cr3 plus. So after Cr3 plus we have Fe3 plus. So it means the charge is the least. Okay. So here the here if the size of the ions is higher, then the lattice energy would decrease. So the size of the okay. Uh, so Mg2 plus will have the least size. Yep. Mg2 plus size of Fe3 plus will be higher. So for Mg2 plus, so here we have Mg2 plus ion and Al3 plus ion, Cr3 plus ion, and Fe3 plus ion. So for Mg2 plus and Al3 plus are isoelectronic, means they have the same number of electrons. And so the size of Al3 plus will be lesser. For Cr3 plus, the size of Al3 plus will be lesser than that of Mg2 plus. And then the size of Cr3 plus will be lesser than Al3 plus, and the size of Fe3 plus will be lesser than Cr3 plus. So when the size is lesser, then the lattice energy will be higher. So it means, therefore, the correct order of the stability of the oxides will be Fe2O3 will be less than Cr2O3, less than Al2O3, less than MgO. So it means that option B is the correct answer. Simply it means that if the lattice energy is higher, then the stability of oxides will be higher. Then here is told that generally the first ionization energy increases along a period, but there are some exceptions. One which is not an exception is generally the first ionization energy increases along a period, but there are some exceptions. One which is not an exception is the first ionization energy increases along a period. increases along a period, but there is one which is not an exception. It's okay. So nitrogen and oxygen, yeah, there is an exception. Since why the expected order is the ionization energy of nitrogen should be less than oxygen, but the correct order is the so it is the wrong order. The correct order is the ionization energy of nitrogen is higher than that of oxygen. So it is an exception. And sodium and magnesium also. In sodium and magnesium has fully filled electronic configuration. So the ionization energy of Mg will be higher than uh, that of sodium. Okay, here actually there is no exception also, since sodium ionization energy should be less than that of magnesium only, since the ionization energy increases along a period. And Mg and Al, yeah, there will be an exception, since why the expected order is Mg should be less than aluminium, but that is wrong. The correct order is the ionization energy of magnesium should be more than aluminum, since Mg has fully filled electronic configuration. So it is an exception here. And for beryllium and boron also, for beryllium and boron also there is an exception, that the expected order is the ionization energy of beryllium should be less than that of boron, but it is wrong. The ionization energy of beryllium is higher than that of boron, since beryllium has fully filled electronic configuration, which is a more stable electronic configuration than that of boron. So here it is also an exception. So only for the option B there is no exception. So option B is the correct answer. Then here it is told the correct order of electronegativities of NOF and PR. So nitrogen, oxygen, fluorine, and then phosphorus is here. So phosphorus is in the nitrogen group only, which is in group number 15. So correct order of electronegativity. So as we know, electronegativity increases across across a period from left to right. It will increase, and down the group it decreases, and down the group the electronegativity decreases. So here it will decrease. So the electronegativity of phosphorus is lesser than that of nitrogen, and across a period again it will increase. So P, N, O, and then F. So for fluorine, the electronegativity is highest, then that of oxygen, then nitrogen, then phosphorus. So FO and P. So option C is the correct answer. Then here it is told the correct arrangement for the ions in the increasing order of their radii is. The correct arrangement for the ions in the increasing order of their radii is. So here we have sodium Na plus and then Cl minus. So Na plus will have 10 electrons, and Cl minus that will have 18 electrons, and Ca2 plus calcium 2 plus ion also will have 18 electrons, and K plus will also have 18 electrons. Potassium ion will also have 18 electron, and S 2 minus sulfide ion also will have 10 electrons. No, will have 18 electrons. And then fluoride ion that will also have 10 electrons. Then Al3 plus ion also will have 10 electrons. And Be2 plus also will have, it will have 2 electrons. So the correct arrangement for the ions in the increasing order of their radii is, so calcium, potassium and sulfur, all they have 18 electrons, so they are isoelectronic. These four are isoelectronic. They are isoelectronic species since they have the same number of electrons. And the rule is, for isoelectronic species, the if the charge is higher, then the radius will be lower. For isoelectronic species, so the rule is, for isoelectronic species, the radius, the radius, or the ionic radius will decrease if the nuclear charge, or I can say if the atomic number Z increases. So here the atomic number of chlorine, that is 17. The atomic number of calcium is 20, Z equal to 20. And for potassium, Z is equal to 19. For sulfur, the atomic number is 16. So it means the nuclear charge is highest for calcium. So for calcium, the ionic radius will be the least. And then K plus, and then Cl minus, and then S2 minus. So Ca2 plus less than K plus less than S2 minus. So option B is the correct answer. Since it says that Ca2 plus, then K plus, then S2 minus. So the size will increase in this order. The, the ionic radius will increase in this order only. Then here it is told, for the properties mentioned, the correct trend for the different species is in. So here, the strength of Lewis acid. So Lewis acid strength. So Lewis acid it means which can accept a lone pair of electrons, which can accept lone pair of electrons. That is called Lewis acid. So here it is told BCl3, uh, boron trichloride, and then AlCl3, aluminium trichloride, and then gallium trichloride. So, so the boron can more easily accept lone pair of electrons. Boron can more easily accept lone pair of electrons. So it means the correct order of Lewis acid strength will be this only. So the Lewis acid strength, I can say Lewis acid strength, it decreases down the group. Down the group. Since why? Uh, Boron, aluminium, gallium, indium, they are in the same group number 13. So down the group, the Lewis acid strength, down the group, the Lewis acid strength decreases. Since why it can, uh, as we go down the group, it can't easily accept the lone pair of electrons. And B is inert pair effect. Inert pair effect. So aluminium here, actually the order should be reverse. Aluminium less than gallium less than indium. Then oxidizing property Al3 plus. So Al3 plus is less oxidizing than In3 plus, which is less oxidizing than Tl3 plus. Tl3 plus is more oxidizing. Since why it can very easily get reduced to Tl plus ion. So Al3 plus can't easily get reduced, so it is less oxidizing. And the order for first ionization enthalpy also, it will, we know that the ionization energy will decrease down the group. It will decrease down the group, and yeah, the ionization energy decreases down the group. But here, thallium, thallium will have more ionization energy, more ionization enthalpy than aluminum also. Since why there is something called as the d orbital contraction, d orbital contraction, and also here we will have lanthanide contraction, lanthanide contraction. So for lanthanide contraction, the since the f orbitals have very less amount of shielding effect, f f orbitals has less shielding effect. So the helium will have more ionization energy than aluminum. So this order of the first ionization enthalpy is wrong. So option A is the correct answer here. Here it is told that for one of the element, various successive ionization enthalpies are given below. The first ionization enthalpy for one of the element, various successive ionization enthalpies are given below. Various successive ionization enthalpies are given below. The element is, so here there is a sudden jump is there. Sudden jump is there in between the third and the fourth ionization enthalpy. So it means that uh, first one is easy, second one is also easy. So third one is also easy, but fourth one is harder. So it means that it can, So it means M3 plus is more stable. So it means that it should be in group number 13. It means that it should here M3 plus ion should be more stable for this element. For this element, since why? Since here for this element, since here the fourth ionization energy, the fourth ionization enthalpy is much higher than the third ionization enthalpy. There is a sudden jump, sudden large difference is there. So it means that it should be Al3 plus ion. Therefore, the element should be aluminum. Element should be aluminum. So it means option D is the correct answer. Then here it is told which one of the following metallic oxides exhibit amphoteric nature. So amphoteric nature. So here sodium, and calcium and barium, they are alkaline earth metals. They are alkaline earth metals. So their oxides will be basic in nature. So they will have basic oxides only. And sodium is an alkali metal, alkali metal. So its oxide also will be strongly basic in nature. And only aluminum oxide, aluminum oxide is it will be amphoteric in nature. Be amphoteric in nature. Since why? Since it can act as a basic oxide also, or it can act as an acidic oxide also. So option B is the correct answer. Then the electronegativities of carbon, nitrogen, silicon, and phosphorus are in the order. So silicon is in the carbon family only in group number 14, and phosphorus is also in nitrogen family only in group number 15. So as we know, down the group, the rule is that down the group, the electronegativity decreases, and period, across a period from left to right, the electronegativity increases. So here down the group electronegativity will decrease. So for phosphorus, the electronegativity will be lesser than nitrogen, and for silicon also the electronegativity will be lesser than carbon, and for carbon also the electronegativity will be lesser than nitrogen. So across a period, the decrease in electronegativity will be lesser than down in the case of down the group. So it means that the electronegativity of carbon will be higher than that of phosphorus. Since down the group, the amount of decrease in the electronegativity will be higher. Here down the group, the decrease is higher, and from right to left, the decrease is lesser. So there is more decrease from nitrogen to phosphorus than from nitrogen to carbon. So for carbon, the electronegativity will be slightly higher than that of phosphorus. So for carbon, the electronegativity is higher than phosphorus. Okay. And from silicon to phosphorus, the electronegativity of silicon will be obviously less than that of phosphorus. And for phosphorus, it is less than that of carbon. For carbon, it is less than that of nitrogen. So this is the required order: S, I, P, C, and N. So option, okay, option B. S, I, P, C, and N. Okay, yeah. So option A is the correct answer. Then here it is told that the orbital nearest to the nucleus is. So here, if the rule is that n plus L rule we can use, if the n plus L is higher, then it means it is more farther away from the nucleus. It is farther away from the nucleus. So here for 4f, the n plus L is n is 4 and L is SPDF. So 3. So that is 7. And for 5D, n plus L value will be 5 plus 2, that is also 7. And for 4S, the n plus L will be 4 plus 0, that is 4. And 7P, that is 7 plus 1, that is equal to n plus L will be 7 plus 1, that is equal to 8. So the orbital nearest to the nucleus, that is also, that will be obviously 4s. So option C is the correct answer. Here also, which of the following is the correct order of radius? Correct order of radius. So here, the option A, here hydrogen, then hydrogen atom, and then hydronium ion. Yeah. So here it is the correct order only. It is correct order only. Since why here the thing is that as the simply if the uh, negative charge increases, if the negative charge increases, then the ionic radius increases, and if the positive charge increases, then also the radius decreases. Since why simply the rule is if the number of the electrons increases, then the radius will increase. And for sodium, so it is the correct order. And in B, it is Na plus, it has got 10 electrons, and minus also has got 10 electrons, and then oxide ion also has got 10 electrons. So here they are isoelectronic species. They all are isoelectronic ions. So for isoelectronic species, the rule is that when the charge is higher, then the radius is lesser. It means if the nuclear charge means if the atomic number is higher, then the radius will be l- lesser. So it means here the sodium ion will have the least size than F minus, which will be even less than O2 minus. So here the option B is wrong option. And similarly, option C is also wrong, since here it is told that F minus has the highest size. So C is also wrong. And in option D, option D, you see it is told that Al3 plus is higher than Mg2 plus is more than Mn3 plus 3 minus. Al3 plus has got 10 electrons. Mg2 plus also has got 10 electrons, but size of Al3 plus will be less than Mg2 plus, since why Al3 plus has got higher nuclear charge than Mg2 plus. So it means option D is also wrong. So the only correct option is option A. Option A is the correct answer. Then here it is told the first ionization enthalpy of the following elements are in the order. So here we have carbon, silicon, nitrogen, and phosphorus. So as you know, the first ionization energy increases from left to right period, across a period, and then uh, and down the group the ionization energy decreases. The ionization energy decreases down the group. So here also the ionization energy of carbon is lesser than that of nitrogen, and the ionization energy of silicon is less than that of phosphorus. Ionization energy of silicon is less than that of phosphorus. So it means that option B is obviously wrong. Option C is also wrong only, since why here it is told phosphorus has lesser ionization energy than silicon. So option D is also D. Okay. So we have to check in between A and D now. Okay. So here phosphorus, now phosphorus is having lesser ionization energy than nitrogen, and silicon also has lesser ionization energy than carbon. Silicon has lesser ionization energy than carbon. Yeah. So in option A is wrong only. Since why here it is told carbon has lesser ionization energy than silicon, which is wrong. So silicon has lesser ionization energy than carbon. So option D is the correct answer, which says that silicon has lesser ionization energy than phosphorus. Phosphorus has lesser ionization energy than carbon, less than nitrogen. Since here the from nitrogen to phosphorus the amount of decrease is higher, and from nitrogen to carbon the amount of decrease is lesser. Okay. So it means that uh, phosphorus has lesser ionization energy than carbon also. Phosphorus has lesser ionization energy than carbon, less than nitrogen. Yeah. So option D is the correct answer. And here it is told that the third ionization enthalpy is highest in the third ionization enthalpy, IE3. Third ionization enthalpy is highest in the case of. So the third ionization enthalpy will be highest in the case of alkaline earth metals. Since why for alkali metals, we know that the M plus ion is more stable. So it means that here IE, the ionization energy 2 will be very high. Ionization energy, the second ionization energy will be very high here. And for alkaline earth metals, the here M2 plus ion is more stable. So here the third ionization enthalpy will be very high. And for chalcogens, chalcogens means the oxygen family. Um, here uh, 2 minus state is more stable, and in nitrogens, which is nitrogen family, here also 3 minus state is more stable. So here we don't go talk about the ionization energy, we talk about the electron gain enthalpy. Okay. So for alkaline earth metals only, the ionization, the third ionization enthalpy will be the highest. So option B is the correct answer. Then amphoteric oxide among the following will be. So amphoteric oxide. Amphoteric, it means that it can act as a basic oxide also, and it can act as an acidic oxide also. We know that silver oxide Ag2O, okay, and then SnO2, which is tin oxide. Uh, it is in carbon family, and CO2 is also in carbon uh, family. So the oxides of the group 14 elements, the oxides of group 14 elements, all will be acidic oxides only. Since why, as we know, CO2 is an acidic oxide, so SnO2 also will be an acidic oxide. So B and D are not correct options. And then BeO, it is a beryllium oxide, which is a oxide of an alkaline earth metal. So it will be also a basic oxide. It will be a basic oxide, since all oxides of alkaline earth metals are basic oxides. Then we have, so it means that Ag2O, which is the silver oxide, this is only an amphoteric oxide. No, sorry. No, sorry. Silver. So it is alkaline earth metal, but there is something called as diagonal relationship. There is something called as diagonal relationship, which means that um, the group two elements, which are lithium, beryllium, then boron, they have got similarity in their chemical properties of the group 3 elements in the no in the sorry in period 3 elements. Okay, they are the diagonal relationship. It means the elements in period 2 elements are similar in their chemical properties with the elements of period 3 in the next group. It means lithium has similar chemical properties with magnesium, and beryllium has similar chemical properties with aluminum, and boron has similar chemical properties with silicon. So it is called diagonal relationship. So it means, since we know that aluminum oxide Al2O3 is an amphoteric oxide, we know that aluminum oxide is an amphoteric oxide. So the beryllium oxide also will be an amphoteric oxide only. So option C is the correct answer. Hello. So here it is told that a pair, okay, uh, the correct order of first ionization enthalpy of the given elements is, so here we have lithium, beryllium, then boron and carbon. So they all are in the period 2 elements. They all are period 2 elements. And as we know that across a period, we know that across a period, the first ionization enthalpy decreases. No, the first ionization enthalpy increases across a period from left to right. The first ionization enthalpy increases from left to right. So here it means carbon has the highest ionization enthalpy, since across a period the nuclear charge increases, the effective nuclear charge increases. So the first ionization enthalpy also increases. So carbon has highest, then beryllium. So in this order it should increase. So it is the expected order. But here for lithium, the electronic configuration is 1s2 2s1, and for beryllium the electronic configuration is 1s2 2s2, and for boron the electronic configuration is 1s2 2s2 2p1, and for carbon the electronic configuration is 1s2 2s2 2p2. So now it means this beryllium has fully filled electronic configuration, so it is more stable, so it has more stable electronic configuration than boron. So here there will be one jump, means the ionization energy for beryllium will be higher than that of boron. So therefore correct order will be the correct order of the first ionization energy will be lithium less than boron less than beryllium less than carbon. So option C is the correct answer. Then here it is told a pair of amphoteric oxides is, that is beryllium oxide is an amphoteric oxide, magnesium oxide is a basic oxide, and zinc oxide is also an amphoteric oxide. Beryllium oxide is also amphoteric, and then aluminum oxide is also amphoteric, and lithium oxide is also a basic oxide, and B2O3, that is boron trioxide, that is also acidic oxide. So it means that here option B will be the correct answer, since both beryllium oxide and zinc oxide are amphoteric oxides, since they act both as a basic oxide and an acidic oxide. Then here it is told that in the periodic table, metals usually used as catalysts belong to the D block. So the D block elements can be used, the D block elements or the transition elements, transition elements can be used as catalysts. So it means that option 3 is the correct answer. In the following, the element with highest ionization energy is, so the first one is neon 3s2 3p1. Now neon has the atomic number 10, so it means that it is having the atomic number 13, means it is it is a- aluminium. So it is the electronic configuration for aluminium. And the second one is neon 3s2 3p3. So this one is having atomic number 15. So it is the electronic configuration for nitrogen. And the third one is neon 3s2 3p2. So it is having the atomic number 14. Okay, 14. So it is the electronic configuration for carbon. No, it is the electronic configuration for, but sorry. Mm, so 15 is the electronic configuration for phosphorus. So 15 is the atomic number of phosphorus and 14 is the atomic number of silicon. So it is the electronic configuration for silicon. And fourth one is neon 3s2 3p4. So it is that, so it is having atomic number 16. So it is the electronic configuration for sulfur. So now all of them are in group number. So all of them are in period number 3. They all are period 3 elements. So we have aluminum, silicon, phosphorus, and sulfur. So, so as we know that the ionization energy increases across a period from left to right. Across a period from left to right, the ionization energy increases. So it means the expected order of ionization energy, expected order of ionization energy will be aluminum less than silicon less than phosphorus less than sulfur. And since phosphorus has got half filled electronic configuration, so it is so it has more stable configuration than silicon. So here there will be one jump. So the correct order of ionization energy will be aluminum less than phosphorus less than silicon less than sulfur. So sulfur has the highest ionization energy. So it is 3 neon 3s to 3p4. So option 4 is the correct answer. Then here it is told among the alkali metals, cesium is the most reactive because. So here so the reason is that so cesium is most reactive since why? Cesium has the least ionization energy. It means that the last electron in cesium is in ns1. So so it has least ionization energy. So the outermost electron is more loosely bound than the outermost electron of the other alkali metals. So cesium can more easily go to Cs plus ion and give one electron. So it is, so cesium, it means that it is a better reducing agent. It is a better reducing agent than other alkali metals. So it is, so its re- reducing ability is the highest among all the other alkali metals. So it is the most reactive alkali metal also. So it is the most reactive alkali metal. So fourth option is the correct answer. Then among sodium Na plus, Na, Mg and Mg2 plus, the largest particle is. So as we know that the Na plus ion will have lesser size than Na. So Na plus will have lesser size than Na, and Mg2 plus also will have lesser size than Mg. Since why the ion will have the cation, the rule is that the size of cation is less than the atom, and the size of the anion is obviously more than the neutral atom. So size of the cation will be less than its atom, and size of Mg will be lesser than Na plus, and Mg2 plus will have the least size. No, sorry, Na plus will have lesser size than Mg also. So here there is Na plus and then Mg here. So it means Mg2 plus has the least size, so it is the smallest particle, and sodium Na is the largest particle, largest particle. So Na. So option 3 is the correct answer. And here it is told an atom of an element A has 3 electrons in its outermost orbit. An atom of an element A has 3 electrons in its outermost orbit. So it means that its electronic configuration is of the form its inert gas core times and then ns2 np1. In this form it has 3 electrons in the outermost orbit. And the electronic configuration of B is it has 6 electrons in the outermost orbit. So it has the inert gas core and then ns2 np4. So it is of this form. So it means that the atom B is in the carbon family, and no, it is in the oxygen family. It is in oxygen family, and A is the in the boron family. It is in boron family. It means that A is an element of group number. It is an element of group number 13, and B is an element of the group number 16. So A can go to A3 plus state, and it can give out 3 electrons, and B can go to B2 minus ion by accepting 2 electrons. It means that the valency of B is 2 and the valency of A is 3. So therefore, the formula of the compound which can be formed in between A and B, the formula of the compound in between A and B, that will be equal to, so for A the valency is 3 and for B the valency is 2, so it will be A2B3. A2B3. So option 2 is the correct answer. Since A has got valency 3 and B has got valency 2, so I will do crisscross and then A3. Okay, sorry. A has valency 3, B has valency 2. So it will be A2B3. Huh? So option 2 is the correct answer. Then here it is told which of the following types of metals form the most efficient catalysts. So the transition uh, metals, or the D block elements, form the most efficient catalysts. For example, like we have nickel, platinum, etc. So these are the uh, catalysts which are oftenly used. So they are the transition metals or the D block elements. So option 3 is the correct answer. Then the elements with atomic numbers 9, 17, 35, 53, 85, these all are the halogens. Since why the atomic number 9 is fluorine, atomic number 17 is chlorine, atomic number 35 is bromine, atomic number 53 is iodine, and the atomic number 85 is At, which is uh, called as astatine. 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 Okay. So all these are halogens which form the group number 17 elements. They are in group number 17, which is just before the group number 18, since group number 18 forms the noble gases or the inert gases. So it means option 4 is the correct answer. So hope all of you understood the solutions of all these questions based on the chapter periodic classification of elements. Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And please install our Sapience education application also, since we shall upload some important homework questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.